Hey everybody, thanks so much for joining. We'll just give everyone a couple more minutes to start hopping in and introduce our virtual meetup speakers today and jump into learning a little bit about LimeChain's Hedera Ethereum bridge and the scheduled transactions functionality. Thanks so much for joining everybody. We'll just give a couple more minutes. All right, why don't we start to kick things off here. So today we're going to be joined by Daniel Ivanov. He's the lead engineer for the Hedera development on the LimeChain team. We've been grateful to have LimeChain assisting as part of decentralized development for certain Hedera features for the Hedera services code base, one of which we'll be learning about today, called the scheduled transactions functionality. Not only that, but LimeChain is also working on software that is part of the Hedera ecosystem separate from Hedera. So one of those things is this Hedera EVM or Ethereum Validator network bridge. And we're going to be learning about how they utilize this software and how that software utilizes the scheduled transactions capability. We also have Greg Scholar, developer advocate at Hedera today, who's going to be joining us. And he'll be able to answer any questions that we have about the scheduled transactions functionality and speak to that functionality a little bit as well. So thank you so much again for joining today. And I'm going to pass things over to Daniel and he'll kick things off.
Thanks, Brady, for the intro. So hi, everyone. I am just going to share my screen first. Let me know if you see my screen. Just a second.
Can
you see the screen?
Yep.
Okay, so you're seeing only the presentation?
That's correct.
Yep. Okay, so a little bit about me and LimeChain. As Brady mentioned, I'm the lead developer behind LimeChain's team, which is responsible for implementing and working with Hedera, the Hedera team on the protocol level and on the application level. I have been in the DOT space for almost 5 years now, so late 2016. And LimeChain is software development and consultancy firm based in Sofia, Bulgaria, as well as a branch in London, England. And we are around 50 developers at the moment at LimeChain, all working on DOT technology. On today, basically, we're going to discuss the bridge that we've been working on and the scheduled transactions that have been recently released. Our team at LimeChain was involved into the development of the Hedera token service a couple of months ago, as well as this new feature that was recently released called scheduled transactions. So we're going to dive into what scheduled transactions are, how they can be used and what for. After that, we're going to go through a high-level overview of how the bridge works. And we're going to have a concrete example of bridging between Hedera to Polygon and from Polygon back to Hedera. As you may know, the bridge works with any EVM compatible chain, and that's not only Ethereum, but Polygon is EVM based as well. So we're going to use the concrete example of Polygon. And I've prepared a demo for the bridge. So I'm going to showcase the bridge that attached to and basically interfacing through my HBAR wallet. So yeah, we can straight dive into it. First of all, scheduled transactions are a new feature that was recently released. It's enabling users to create a normal transaction without all of the required signatures at first. So if you have a threshold account, for example, that has a 3 out of 5 signatures required in order for the transaction to be valid, scheduled transactions enable the users to create the transaction, for example, a crypto transfer, with only one signature, only 1 out of 5 public keys signing that transaction. And that transaction is created as a pending one. It has its own schedule ID, and it stays pending until expiration or deletion, or until all of the required keys have signed the transaction, basically authorize that transaction. And in our example, 3 out of 5 public keys have provided their signature. In that case, the transaction is immediately executed after the schedule sign transaction. That was the one that provided the third signature. So let me give you a concrete example here. And I'm going to show you an example of a transaction record after that for a scheduled transaction, sorry. So here's a concrete example. We have an account A, which is a threshold account, 3 out of 5. It's basically similar to a multi-sig account. 3 signatures are required for the account to authorize transactions to be executed. And normally, when you want to do a crypto transfer, for example, sending 10 HBARs from account A to account B, 3 public keys have to provide their signatures in order for them to be 3 out of 5 and the transaction to be executed. Otherwise, the transaction won't execute. Using scheduled transactions, you can do the following thing. You can schedule a crypto transfer that sends the 10 HBARs from account A to account B, but you can create that transaction only signing using public key 1. So this is extremely important when you have a threshold account and you have a couple of public keys that have to provide signatures. You have to coordinate between each other, aggregate those signatures, and submit them with one transaction. What scheduled transaction enables is for each entity that basically has access to one private key to create the transaction without communicating with the other 4 in this case. So we can create the crypto transfer, scheduled crypto transfer, from entity 1 that signs using public key for the first using the first public key, basically. That creates the scheduled entity, and it does not execute immediately since there are 2 more public keys that are missing that haven't authorized this transaction yet. So it stays pending, and at some point, entity 2 that has the private key for public key 2 executes a scheduled sign transaction. In that case, the public keys that have signed the transaction are 2 out of 5. So it's not yet ready for submission, for execution. And it doesn't do anything. It just marks it as 2 out of 5 provided. After that, when the third one does a scheduled sign operation, and that's a separate operation that was introduced from the scheduled service. So we have a schedule create that creates a scheduled transaction, and we have a schedule sign. Schedule sign just provides signatures, basically authorizes the transaction, and if there's enough signatures that have authorized it and it activates that scheduled transaction, it's executed. So in our case, a schedule sign performed by the third private key, so the third signed by the third private key, will execute the transaction immediately after the schedule sign operation is finished. So in just a second. Yeah. Okay. I saw that there are some questions here, but we'll talk about them later. So that's the gist of scheduled transactions, and I'll show you a transaction record directly from the Mirror Node team. Here we can see that there's a query to the testnet Mirror Node, and we're querying for this specific transaction ending in 26. We can see that there is a transaction ID ending in 26, and a property here, that's something that's newly introduced, a new property here called scheduled false. It's scheduled and it's in the variable is false. That's the original schedule create transaction, the outer transaction, and not the inner one, which is the crypto transfer. So it has its own transaction record, and we have here a transfer list only for the paying the transaction fee for the schedule create transaction. However, if we can see here, we have another transaction record with the same ID as the one with the schedule create operation. And we can see here that the name of the operation is crypto transfer, and that's the inner transaction that is being scheduled. Another thing that we can see is that the scheduled property is set to true. That means that this transaction is actually triggered because it's a scheduled transaction. It's triggered by this transaction, the schedule create one. So once the crypto transfer is here in this transaction record, means that it already executed and all of the signatures have been provided. And we can see the transfers in that transaction. They look like a normal transfer list that has a couple more transfers than usual. So we're not sending, in our example, 10 HBARs from account A to account B, but we have a more complex one, and that's an actual transaction from the bridge that after that we can discuss in details. So that's a general overview of what scheduled transactions are and how they can be used and what they are enabling. The important thing is to remember that entities owning private keys as part of a threshold account can execute transactions without the need for them to communicate with each other and aggregate the signatures, sign them independently, send them to one entity, and that one entity to create the transfer. So that's the real enabler here. Greg, do you want to add anything on scheduled transactions, or do you want to go to the overview of the bridge?
Just a quick note that multi-sig was or has been available since the very beginning of Hedera. The accounts and other entities have always been multi-sig. So what scheduled transactions really do is make it easier for multiple parties to contribute their signatures to a particular transaction, where in the old days or before scheduled transactions, you had to transfer the transaction data between the users and collect the signatures and then submit that transaction within approximately 2 minutes. Scheduled transactions make that process much easier to implement with a window of opportunity of 30 minutes to sign transactions.
Yep, exactly. Summarized it perfectly. Yeah, so now I'm going to discuss and basically explain how we are using scheduled transactions in the bridge between Hedera and EVM chains. The code is open source. So just maybe a recap. A bridge in DOT terminology refers to most probably a network of validating nodes that are responsible for transferring assets or information between one network to another, in this case from Hedera to EVM chain and back from EVM chain back to Hedera. So it's a two-way bridge, and the code is open source. The validator node is in GitHub, maybe I should send out the link. I forgot to add it here in the presentation. But maybe we can send the presentation afterwards somehow and add the link there. Okay, so first thing here, we're going to go through the Hedera to Polygon site. The process starts by Alice sending HBARs to a specific threshold account called bridge account. It's a threshold account that's controlled by the validators of the network. Each validator listens for incoming transfers to that bridge account. And once they see a new transfer, they are basically creating a scheduled transaction that in itself does a crypto transfer for the fee of the bridge. So the bridge has service fee. It's, for example, we can use an example of 1% for the asset. So if you're transferring 100 HBARs, it's going to have 1 HBAR as a service fee. And that service fee is extracted by the validators using a scheduled transaction. We couldn't have implemented this without scheduled transactions. After that, once the validators extract their fee, validators are providing their signatures. Basically, they are signing a cryptographic message signed by an Ethereum private key, and that's recovered in the smart contracts afterwards. So each validator provides their signature on authorizing the transfer. Once they provide their signature, they're basically, by providing, we are referring to submitting it to a topic in Hedera consensus service, so it's public and auditable by everyone. Everyone can see the signatures there. The signature encodes information such as who is the receiving address of the asset, what's the amount, and the transaction identifier on the Hedera side to protect against replay attacks. So validators provide their signature, and Alice can get the signatures from the topic message, basically getting the messages from the Hedera consensus service topic, and Alice sends those signatures to a contract on the EVM chain. The contract itself does EC recover, basically recovering the signatures and verifying that they are signed by the validator set and the signatures have a supermajority. If that's true, the bridge contract mints a wrapped HBAR, basically an ERC20 equivalent of HBARs to Alice's address. And if we here's basically an example, a diagram on the process. We can see here step 1, transferring HBARs to the bridge account. Step 2, or actually before step 2, we can see validators watching that bridge account. Once they see an incoming transfer of HBARs, they are extracting the fee using a scheduled transaction. I'm going to show you that in a demo afterwards. Step 3 is providing their signatures, submitting them to HCS topic. That at that point, the user can get those signatures and submit them to the EVM contract. So in this case, Alice gets them from the HCS topic, so to say, and submits them as a transaction to the EVM contract. That contract itself means the wrapped HBARs to the Alice's address. And you can see the distinction between Hedera hash graph and the EVM chain. What part of the steps are on the Hedera side and what's on the EVM chain. That's a general overview of how Hedera to EVM chain works, and you can bridge any asset that's supported by the bridge. So far, we have support for HBARs and for HTS tokens. But in order to add a certain type of HTS token, you have to basically add it as explicitly as support in the bridge. So you cannot add an arbitrary HTS token without the bridge supporting it explicitly. If we want to see the flow of the asset, actually, here we can see it. Alice sending 300 HBARs to bridge account. At that point, a scheduled crypto transfer from all validators is executed, and the only reason behind that is to extract the service fee. In this case, the service fee is 1%. 300 HBARs equals to 3 HBARs as a service fee. Each validator gets 1 HBAR to their Hedera account. So they are accruing native HBARs. They are not accruing wrapped HBARs or something. And at the end of this process, 297 wrapped HBARs are minted on Polygon to Alice's Ethereum address. That's basically an overview, a simplified version of what's going on for Hedera to Polygon. If you want to go through Polygon to Hedera, it's actually simpler compared to the previous one. Here we have less steps. The user has to execute only one transaction. Everything after that, everything's performed by the validators. So first, Alice wants to transfer her wrapped HBARs on Polygon. Remember, HBARs are not existing as a native token on Polygon. They're wrapped ERC20 tokens. So if you want to bring them back to Hedera, you have to burn those wrapped HBARs. And in order to do that, Alice has to create a burn wrapped HBAR transaction and send it to the EVM contract, in our case on Polygon. And that basically first of all burns the wrapped HBAR, and second emits an event for that burning. That event specifies the receiving address on Hedera. So validators, when they watch for burn events in order to react and transfer those assets to Alice's Hedera account, they are going through the burn events. They are getting the information on the asset and the receiver and the amount. And once they have that information, each validator on their own creates a scheduled crypto transfer transaction, the same way we do for the Hedera to Polygon site for extracting the fees. The scheduled transaction not only includes the transfers of the fee, but actually the outstanding amount that should be transferred to Alice's Hedera account. So remember, if you want to if you want to bridge something to Polygon, you're sending it to that bridge account. If you want to have it back on Hedera, the bridge account is used to basically send the HBARs to the receiving address. So if we see here the flow, the assets, we can see that burn event of 300 wrapped HBARs is emitted. Validators create the scheduled transfer. Keep in mind that each validator has only one private key, and the bridge account is configured as a threshold account with more than 50% requirement for the threshold. So if there's 3 validators, 2 validators should provide their signatures and the transaction will execute. In this case, each validator creates the scheduled transaction and signs it. And after that, after 2 out of 3 provided, the transaction is executed. And the transaction itself does the following thing. First, it debits the bridge account with 300 HBARs, and it sends 1 HBAR to each validating account for the service fee, the same service fee that we have previously for Hedera to Polygon. We have it here as well. And other than sending out the service fee to the validator accounts, the bridge account sends the 297 HBARs to Alice's Hedera account. So she receives the 297 HBARs from her 300 wrapped HBARs minus the service fee, in this example, 1%. So let me demonstrate that process here. This is the HBAR wallet user interface. It's hosted, it's working on, basically this is a forked repo of the HBAR wallet, and we've added the bridge integration here in this user interface. So I'm going to access my account here. So it's a testnet account, so do not worry about the private key. Don't do that on mainnet though. Let me access my account. Okay, here's the usual HBAR wallet interface. There's another section here, a bridge section, and we have transfer to Polygon and transfer to Hedera. We can choose the asset that we want to transfer. In this case, let's transfer HBARs. We have to connect our wallet. It's required because, as you remember, Alice has to sign an Ethereum transaction, the Polygon transaction that she'll claim her wrapped tokens. So I've already configured my MetaMask to the Polygon testnet called Mumbai. So I've connected my wallet, and I'm going to specify my address as a receiving address. I'm going to transfer 100 HBARs. And here we can see some general information on the transfer. We can see the asset, we can see the receiver, the amount. In this case, in our test environment, we are using a 10% service fee, which is quite high, but it's just for easier calculations. So 10% out of the 100 HBARs, 10 HBARs that are going to be received, split up by validators. And the total to receive is 90 wrapped HBARs. First step here, as I already mentioned, first step is to transfer that 100 HBARs to the bridge account. So we are doing that transaction here. So we're depositing our assets to the bridge account, and it already went through. We are waiting for validators confirmations here. So at this moment, in the background, validators are creating the scheduled transaction that extracts the fee and provide their signatures. Here in this user interface, we've received the signatures, we have them in the browser, and we can basically submit them as a Polygon transaction to claim our HBARs. And we can do that. Obviously, we have to sign it in MetaMask. So I'm signing that transaction. And we're going to wait for the claim transaction to be mined on Polygon. It should be fast. It's faster than the Ethereum mainnet. So we should see a success. Yeah, here it goes. So now we have two transactions that are displayed here, the Hedera and the Polygon transaction. The first one, you can see it's a crypto transfer, sending 100 HBARs plus the transaction fee from my account ending in 359, which is basically this one, 359. And the receiving one is the bridge account. Here it is, ending in 520. The second transaction is on Polygon. This is the Explorer, and we can see that the transaction is basically token minting of 90 wrapped HBARs. The one at the end is basically the remainder, since you cannot divide 10 HBARs equally to 3 validators. The remainder, one tiny bar, basically is sent to Alice's address. So here we can see the minting, and that's basically the the flow from Hedera to Polygon. And at this point, we have our asset. We have our wrapped HBAR on Polygon. We can do whatever we want with it. It's an ERC20 token. If we want to get it back to Hedera, though, we can go to the transfer to Hedera page, and we have the assets here. we have the wrapped HBAR, we have some demonstration token here. We can connect the wallet. I've already selected, keep in mind that you have to select Mumbai testnet here. And I've connected my wallet. I'm going to send the wrapped HBARs back to my Hedera account. Let me copy the account again. This is my account. And I'm going to transfer back 90 wrapped HBARs. Let's see how it goes. So here, if you remember, we have only one operation. As per the diagram that I've showed, the user has to only deposit their wrapped HBARs, which in terms will burn it under the hood, will emit event, and the validators will process it and send the assets. And let's see how it goes. So first of all, we have to sign a message here. In ERC20 world, there's the concept of approve, and in order for the bridge contract to burn the tokens of my account, I have to first approve it. One way to do it is to create a separate transaction for approving it. In our case, we decided to implement the permit functionality, which is basically I'm going to sign with my MetaMask authorization and use it as part of my transaction so that the contract can use my authorization and send it to the ERC20 contract and say, okay, I want to burn that amount of funds from that person. Here's a signature from that exact person that he authorizes me to do that. So I've signed that message. And here's the transaction that actually sends that signature as well as the other information to the burn to basically execute the burn operation. So in this transaction, we have the signature that I'm approving for the contract to burn my tokens, as well as information on where to send, what asset to burn, where to send the funds to in terms of Hedera account, and how much. So hopefully everything goes smoothly here. We are waiting for block confirmations. Okay, so what happened here in the background, the contract emitted the event, the validators listened for that event, and they reacted to it. And how they reacted, let's see. First let's see the Polygon transaction. We have the token burning that burned 90 wrapped HBARs from my address to the zeroed address, and that emitted an event. I think that we can see it here. Approval, transfer, burn. Yep, here it is. Here's the burn. Here's the account. Here's the asset that we want to burn, the amount that we are burning, and the receiving address. This is the receiver in Hedera, in terms of the Hedera account. The next thing that we can see is the Hedera transaction. We have two transactions here with the same ID. As I mentioned, validators in the background are executing a scheduled transaction that first we can see the schedule create here, executed, and we're paying only for the transaction fees. The second is more interesting. That's the inner transaction that's being executed. That's the transaction that's being scheduled and at some point executed. And at some point is basically when the majority of the validators sign the transaction. So here we have a crypto transfer that's scheduled with the same ID, and we can see the following data here. So we have a transfer list paying out the fees, but the important thing is that from the bridge account, from the bridge threshold account, which is operated by the validators, we are removing 90 HBARs, and 3 HBARs are sent to each of the validators accounts, and the remainder is sent to my address, which is ending in 359, which is the same as this one. So that's the end-to-end scenario for transferring between Polygon and Hedera. demonstrated. Let me see if I can go back to the presentation. Okay, so yeah, I've left some time for comments and questions. Do we have something on the chat? Are there any questions, guys? I think that there are.
So it looks like we have one question from someone that says, why is the time limit on the scheduled transaction 30 minutes? Is it arbitrary or is there some technical basis for that?
Yeah, so that's a good question. First of all, the version of scheduled transaction released at the moment is kind of limited. Ideally, we would like to create scheduled transactions that not only collect signatures in time as we do now by the different actors, but execute it at a given time in the future. The limitation around 30 minutes lies behind the fact that the transaction bytes are stored in the Hedera nodes, and we don't want to risk any DDoS potential attacks. We just want to limit that vote and basically that memory to 30 minutes. After 30 minutes, the scheduled transaction expires and it's cleared from memory. So we are using that, and the combination of expiry of 30 minutes and the combination of and actually having a throttle on the Hedera node that limits the number of scheduled transactions that could be created any given second, implicitly enforce a certain limit on the number of scheduled transactions that could be in memory. So we are protecting the nodes from being overloaded with a lot of transaction bytes to store.
Excellent. Thanks for that explainer. Let's see if there's anything else that's coming through. Not seeing any other questions so far. So we have another question that came through. How quickly will we be able to get exposure to DeFi products on Ethereum applications like Aave, Yearn, things of that nature?
Yep, that's a good question. At the moment, the status of the bridge is it's technically implemented. There's a couple of things that have to be sorted out on the productizing side. We are working with the Hedera team and other organizations in the DOT sphere that are partnering with Hedera to be able to basically bring the bridge to life. And once we do that, users, one of the main reasons that we focused on the bridge and why we implement is to be able for users to bridge their HBARs or HTS tokens to Polygon or Ethereum and use them and basically use the DeFi products there, Aave, Yearn, etc. So that was the main goal, and at the moment we're working on productizing the bridge and releasing it to public. It's only technically implemented now, but that's one part of the task here. Or HTS tokens to Polygon or Ethereum.
And it looks like we have another question that came through. Could NFTs be also used in this manner? So multi-signature Hedera to Polygon or vice versa?
Yeah. So the question for NFTs is a little tricky, but we do have a plan for that as well. So the contracts that are implemented for the EVM are easily extendable, and support for NFTs can be added as well. In the future, we want to add support for NFTs. We want to be able to bridge NFTs from Hedera to Polygon, and it refers to the upgrades that are coming to HTS, basically being able to issue non-fungible tokens more easily on HTS is one of the things that we are working on, and that once that's ready, we will be for sure going forward with basically adding support for NFTs on the bridge as well. It's not something that is not impossible. We already have thought about it, and we know that at some point in the future, NFT support must be added to the bridge as well.
Thanks, Daniel. And then another question for myself, actually. So I know that there's the possibility to bridge Hedera with, we're using Polygon in this example, Ethereum. Would there be other networks that are sort of next in line that we're looking to bridge to? Something like XDAI network or Binance chain, anything like that?
Yeah, so the current status of the validator node is to have support for only, so the pair between Hedera and an EVM chain is 1-to-1. And we are thinking about extending that validator node so that the validator node can support pair of Hedera hash graph to multiple EVM chains. So basically with one validator, you'll be able to process transactions from Hedera to Polygon to XDAI to Ethereum, whatever EVM chain we want to add. It would be added simply as adding a couple of configuration on the application properties, the environmental variables of the node. So we do want to add support for one bridge network to work with multiple EVM chains. So yeah, I hope that answers your question.
Yeah, definitely. And then, so, going back to the question about using wrapped HBAR specifically, would there be liquidity pools that are created on these DeFi applications? Is that something that has to be requested by LimeChain or Hedera, or how does that work exactly? Like,
it's interesting to see how the DeFi ecosystem grows. Whenever you have some new token, it's almost instantly added everywhere. For example, if you see a new token on Ethereum, it's almost instantly added as a trading pair in Uniswap. It's added into DeFi protocols out of the box very quickly. So I would not. I don't think that we'll have to do anything on our side in order for wrapped HBARs to get added into DeFi protocols. So I do expect that it will come out of the box once we get wrapped HBARs live on an EVM chain like Polygon.
awesome, that's really exciting. Very cool. So far it looks like we haven't had any more questions come through. Maybe we'll give it one more minute. If anyone has any last questions for Greg or Daniel, feel free to drop them in the chat. Otherwise, we will say goodbye for now. And it looks like Marco is the one that was asking about exposure to DeFi products, and he says thank you for the answer, Daniel.
My pleasure.
Cool. Well, it looks like no more questions. thank you, Daniel and Greg, both for joining and doing the demo of the Ethereum to Hedera Validator network software. This has been super interesting and really looking forward to further developments of it and being able to allow the community and anyone who wants to participate in DeFi with HBAR. Seems like the best way to do it so far that I've seen. So thank you again. We'll be posting this in the virtual webinars playlist on YouTube, so folks can feel free to go back and watch it. And then I think LimeChain is also going to be doing a sort of technical blog posting for developers to be able to learn a little bit about using scheduled transactions, building bridges of their own, or just utilizing scheduled transactions in general for their applications. So be on the lookout for that. And yeah, just want to say thank you again, everyone, for joining, and we'll see you soon.
Thank you, Brady. Thank you, everyone.
Thank you all.
Bye.